Okay, it's recording now. Okay, so much for technology. Did I mention that I have a doctorate degree in information systems? Okay, so, okay, so here is your presentation. Okay, it's gonna have, you're gonna state your research question, you're gonna talk about the data, univariate statistics, bivariate stats, logistic regression model. Okay, so the research question, who are most likely to open a CD? That's what the bank wants to know. It's who and what levers do I have to make them, okay? So remember, the who is things you can't change about someone, okay? So if single people are more likely to open up a CD, you can't make someone single. Either they are or they aren't. If they're married, you can't do anything about it. Because if you get them divorced, then they're a divorce category. And if they're divorced, they're already divorced, they can't be single. Okay, you're going to talk about the data. Guys, this is the last review here, and it's recording. So the data. So you're going to state, where did the data come from? You have documentation on that. How many observations? There are 21 variables. You are going to describe all the variables, okay? If you need to do this in a few sheets, so be it, okay? Describe the variables. This is your documentation for the study. Then we get to, so we're going to go with univariate statistics. So we created these univariate stats on continuous variables. We did this in SAS by using the distribution analysis, was it? The summary statistics. There we go. So in summary statistics, we grabbed our data, we got all our continuous variables, and it produced this for us. This was an example of what not to do because we had here a classification variable, which we shouldn't use. So let's just run this again. Okay, and so this produces our statistics on all the continuous variables. So we have an average, we have minimum, maximum, number of missing, none are missing, that's great. When we do this over here, and we ask for our plots, just to go back and see how we ask for our plots, we go here onto options, and in plots, we ask for the histogram, okay? So we said that you can include these histograms in your study. It would be nice if you even copied them to appendix, but especially if you want to talk about a variable like p days, because p days has most everyone here in this very large number, while very few are here. So it's very unlikely that p days is going to have much a relationship with anything, because everybody is, it's very homogeneous. Most people are just here, okay? But we'll see what the analysis gets us. Okay, so univariate statistics for the categorical variables, we are going to use the one-way frequencies. Here we go, one-way frequencies. So one-way frequencies are here. And the main thing that we talked about here was that in your data, you can get all your categorical variables, all of them, okay? Just put them there. You hit the run button. But in your one-way frequencies, it's in the options. That's all good. Maybe we can take that out. Okay, so the good thing about this is that we can see we have our frequencies, the percent of the population that it corresponds to. And again, when you have something like this, you can say that, again, most people are admin, blue collar, services, technical. Okay, makes sense. Hey, the unknown seems to be kind of small. Go back here. There's only 330 of them out of a population of 40,000. Well, it's a small number. Maybe it's still valid, maybe not, but at least you're aware that unknown really doesn't have too many. Here we chose to look at, I chose to look at single, married, and divorced. In unknown, well, unknown is a category with only 80, so that's really small. So we really don't care about unknown. We saw that when we ran this, we saw that it was significant, okay? Oh, I'm sorry, that was in another analysis, sorry. We can see that, okay, we have our distribution, fine. Most people in this data are what? Married. 60% are married, 28% are single, 11% are divorced, okay? Going here to bivariate statistics. We use the t-test to compare the variable y. So all bivariate statistics are again against y. So the continuous variables, we're going to use the t-test. Okay, it's going to result in a no yes. It's going to have averages. Here we ran the t-test. Let's go over here, take a look at the t-test. Okay, so the t-test, two sample test, analysis variable, we chose the consumer price index. The variable y is the grouping variable. When we saw the results, we found our p-value to be significant, and we brought in this table over here. So let's take a look at what we brought in. We said there is a significant relationship between y and consumer price index. When the consumer price index is lower, here it is. This is lower. When it's lower, people tend to open up CDs, the yes, okay? Even though it's a small difference, it's a significant difference. So we're just reporting it. Now, when you're dealing with two categorical variables, meaning the y is categorical and the other variable is going to be categorical as well, we do a table analysis in SAS. So a table analysis is right over here. This one over here. So what we did for the table analysis, we have the data. We have row is the variable that you're looking at. Everything is going to be against y. It's just organizing the column here. If not, the table is going to be flipped. It's going to be more difficult to see. The other important thing that we did in options is that we're suppressing plots, frequencies observed, percentages are row. Make sure that in your statistics, the chi-square statistics are checked off. Okay, we ran this. Our chi-square test is significant. It's below 0.01. We copy this table over, and here it is. So there is a significant dependency on opening SAD with marital status. Married and divorced people seem to be similar, 10.32 and 10.16%. Singles are the most likely to open a CD. If you are single, 14% open up a CD. We did our logistic regression. So binary logistic regression, we go over here, binary logistic regression. So in this model, you guys will do interactions, but anyway, you define your continuous variables, your categorical variables. Most importantly, your response variable is a y, event of interest is yes. In your model, you guys will try to take a look at interactions. I did not here just for the sake of runtime. And then in selection, you'll do backwards or stepwise, but change this to a 0.01. This is significance for a variable to enter the model. We run this, and we got all this. So the second to last table is the most important table to bring in, okay? The last table are the odds ratios. Sometimes you may use it, sometimes not. But this is where we looked at, for instance, well, first of all, we take out and we say which are all the variables that came out to be significant in the model. We create our model. So this is plus a bunch of stuff. Week times contact. This would be this, this times this would be an interaction. You can also do it like this, okay? Most importantly here is the model interpretation. So each predictor, you're going to list it, and you're going to make a comment. So in month, we said that the best month to contact someone to open a CD is March, followed by August, and the worst are May, June, and November. So the month of March has the highest coefficient, followed by August. So these are the best months. And the worst are the ones with the biggest negative coefficient, which would be here, here, and I forgot which other one. Probably this one over here. Okay? We talked about contact. So the best contact is the one, so 0 is a reference point for telephone, and this is a higher one. So cell phone are better to contact someone. Okay? And if we look at the odds ratio of contact cellular versus telephone is 1.76. So here we state cell phone is the best way to contact someone to open a CD. The odds of opening a CD when contacted by cell versus telephone is 1.76. In other words, contact people by cell phones.